We are here today with someone I'm very excited to actually introduce you to because I have followed her on social media for probably a decade. So it is my joy and my delight to introduce you to Sherri Seligson. Hello.
Hi, good to be here.
Right. I followed you for a long time, so I know some little parts about you. I know that you are into biology and science and various other things. My special memory is reading something you wrote on the hydrological cycle, faith and God, and I used it with my boys who loved it. I mean, that's where I started. That's where I first found you. So do you want to just let's just start there. Just tell us about that and tell us a bit about yourself as well.
Yeah, well, so I'm educated in pre-med medicine, and I actually worked as a marine biologist. I live in Florida in the U.S., and so swimming, diving, being in the ocean was like part of my life, and fascinated with ocean animals. So I worked as a marine biologist at Walt Disney World for 10 years, and did published research on shark behavior. And yeah, regarding that article I wrote in just studying scripture, it's interesting to see. God made everything. And of course, he would know how the world works, even more than we would know how the world works. So there's clear evidences of that, such as the fact that air has mass. There's Bible verses that talk about the weight of air, the mass of air. Whereas back in the days that when the Bible was written, air was nothing. It wasn't considered made of anything. The hydrologic cycle in Job is mentioned about how the cycle of evaporation from the waters of the earth, and then condensation into clouds and precipitation onto land. That's the three major pieces of the hydrologic cycle. And they're mentioned specifically, not those words, but he draws up water in air, which condenses and falls as rain. It's fascinating to me that thousands of years before the discovery of the hydrologic cycle, I think Bernard Palissy in the 1800s is the gentleman who's credited with identifying that as a cycle. That's already in the Bible. And it was just fascinating to me that there's so much scientific wisdom and truth, because God knows how the world works. And that's why I love studying science, because it helps give us clues and more glimpses of God's behavior, who he is. And there's a lot of knowledge in the Bible too.
I want to come on to some specifics that you've got some particular knowledge on, but what made you want to go into something like marine biology, which, I mean, I can understand the passion. I think immediately with dolphins. That's my brain straight away goes to dolphins. How cool is that? But obviously there's much more to it than that. What drew you to wanting to work in the oceans?
The fact that we know so little about them. So yes, most people think that my life as a marine biologist was spent riding on the back of a dolphin into the sunset.
That's my view.
Yeah, I did that. Never. I did play with them and work with them, but no, we never got to ride. Yeah. Anyway, so, but what would interest me was we know so little about our oceans because it's such a different environment. We're all this crazy material or send down submersibles just to view it. We know more about the surface of our moon than we know about the surface of our ocean floor. And regularly, weekly, we are discovering new species of animals that live in the ocean depths. And so to me, it's like a giant seek and find or a mystery that I get to solve and learn more about. And so that's what drew my interest to look more into it. There was just so much to study, and everything was new and exciting. Plus, I love the ocean. I love to swim and dive and fish, and to be able to get paid to do that was really wonderful. So
it's a win-win, isn't it?
It is. Yes.
Right. Now, the one that I definitely want to talk to you about is, because I shared this on my show, that we were going to talk about this, the subatomic periodic table, which I love the fact that I don't know the periodic table. I could probably say lithium, magnesium, hydrogen, and I'm starting to run out of them. But there's a whole other, I mean, this is science. There's a whole other like table of stuff.
Yes. Yeah. Much to students' chagrin. They're very upset to know there's more to learn. But yeah, so one of the things I do now is I instruct students in all middle and high school level sciences, and do a lot of study in that and education in that. And in my research of chemistry, the periodic table of the elements is this beautifully elegant table. When you look at it, it just looks like a lot of boxes and letters, but it is packed full of information. Just looking at a box, it can tell you what like, for example, the carbon atom is made of, and how it is compared to all the other atoms that exist, and how it's going to interact with those atoms just by looking at the box. And so it's just a fascinating, elegant table, and it's designed in such a way that it's periodic, that elements such as carbon and hydrogen and oxygen, they're in columns, and they are in columns because they behave the same way. They have similar properties. They're in rows based on their increasing ability to do things and masses and such. And so as scientists have began learning more about subatomic particles, meaning particles that make up atoms, protons and neutrons and electrons, and there's muons and all kinds of unique smaller particles. They're not stable in nature. They don't exist like on their own usually. So the smallest unit is an atom, but below that there's more of these pieces and parts. And scientists began to organize, because we love to organize things, how they behave. They have different kinds of spins, left spin, right spin, magnetic behavior, mass, how they behave. And so they started organizing them in a table, and they realized this table is periodic. It has comparative differences. And so there is now what I call a subatomic periodic table of subatomic elements. It's another table, and that is fascinating to me. The order and organization in creation is just fascinating. How when we discover something, we can say, well, there must be something before and something after, because we see this natural order. And that's how the whole elements of the periodic table were discovered. There were blank spots, and scientists were looking for those blank spots because they said, well, there's one that has a mass of 17 and one that has a mass of 19. There must be an atom somewhere that has a mass of 18. And that's what they're doing with the subatomic particles as well. They're looking for more. They take atoms and they blast them with neutrons and other things really hard, and they wait to see what comes out. And that's where they discover all these amazing subatomic particles that are ordered and organized. And that just blows my mind. This is amazing.
Yeah, I love that idea of ordered and organized. Here's my knowledge. I didn't do very well at science. My the extremes of my knowledge are there's hydrogen and helium, and one of them's not so great with fire. And that's kind of where my knowledge goes. But I also know they're in the same little column because they're connected but different.
Yes, exactly. They only have one proton of difference. Hydrogen has one proton, helium has two. But the difference is this, and this is something kind of cool. I love to tell students, this is like a story in a sense. The whole reason that all of our atoms behave the way they do in chemistry and chemical reactions occur is all atoms desire to have what's called this perfect state of a filled outside electron shell. Their outer shell can only hold so many electrons, and they like them full. And so if they can't fill them up, they'll take electrons, they'll share electrons, they'll give away electrons, whatever they can do so that their outermost shell is full. And helium has a full outermost shell. So it's happy. It's called a noble gas. It's the noble gases are all the ones, they're noble. Just think of them as like they're sitting back on their throne. They're not doing anything. They're not going to react because they're happy. And so hydrogen only has one electron in its outer shell, and it wants another one because it can hold two. Helium has those two in its outer shell. And so hydrogen combines with all kinds of things, with itself, with other atoms, whatever it can do to get that feeling of a second electron. And that's why it's way reactive, because there's loose electrons floating all over the place. And so lots of things want to work with hydrogen. It's just fascinating to me. It's like a story. You can make it a total story. Totally cool.
Yeah. And it's what I love, because there's, like, you use the word order and organized. And although I didn't do very well at science, it was not my thing, I still saw and remember the order of that table. There is an elegance to that. And there's a reason why. And like you just explained with the noble gases, I can remember that'll stick in my head. The noble gases, they're just chilling. That's right.
They don't do much. That's why we don't have to worry about them exploding around us or anything, because they're not going to do anything. They're happy. Yeah.
Cool. Okay. So something else that I want to talk to you about was something you mentioned, bioluminescence. Before we go into that, what does that actually mean? Because bio to me means something alive. Luminescent just means it's like bright. That's probably not very good.
Well, and it's light that's created by living things, living organisms. And so most lights, particularly the incandescent light bulbs and things that we're most familiar with, they generate heat with light. the light that living organisms produce, such as like fireflies or lightning bugs, whatever you call those, there's bunches of them that live in the ocean that create their own light. It's a type of luminescence called chemiluminescence, where they use chemicals, tie back to chemistry, where the chemicals, when they combine, they create this light, but it's a cool light that won't burn up the animal, which is very important, because if they created light, they would burn up and die.
That would be bad.
So that would be bad. They would not survive. So this bioluminescence ability is actually pretty fascinating. And in studying bioluminescence, actually, it was a way of studying populations of a specific kind of bacterium that scientists knew, because they wanted to learn about bacteria. We were talking earlier about how the research in molecular biology has just exploded. Microbiology has exploded with new techniques, new abilities to see what's going on, new processes that can help us identify DNA. And so that area of science is exploding and growing rapidly. And the more they're discovering, the more they're being astounded by some of these things. And this in particular one is a bacterium called Vibrio fischeri. And we can talk more about it if you'd like to. It's a fascinating discovery of bacteria not being simple. And so we talk about complex organisms and simple organisms. Vibrio fischeri is a bacterium that won't glow on its own. So if you have a small concentration of them floating in a solution, they're not going to glow. But if you feed them, wait for them to repopulate, they can repopulate. Bacteria, they go from 2 to 4 to 8 to 16 every 20 minutes. They double. And so if you let them sit in a solution, then they will all of a sudden glow all at one time. And so scientists are like, how do they know what's going on? How they don't have eyes, they don't have ears. How do they know how many of them are there? Every time there's a specific concentration, they turn on this group ability of glowing. And so they began to study these guys. And so these guys live inside little pouches in a tiny squid called the Hawaiian bobtail squid. Mm-hmm. And so squid tend to be a little bit luminescent or light will shine through them. And so when the bacteria glow, the squid glows. Well, the squid is nocturnal. So he sleeps in the day, buried in the sand. And in the morning or at night, he comes out of his burrow and he begins to hunt. And so the bacteria glow and the squid glows. Well, what the squid also does is he has a sensor on his back that can identify how much moonlight there is. And he has some shutters that cover those pouches of bacteria. And so he will identify how much moonlight there is and then adjust the little shutters on his pouch to match the amount of moonlight so he creates no shadow. So he's kind of like the stealth bomber of the ocean. He can hunt without being seen. And if like a cloud comes over and covers the moon and there's less light, he'll cover over those little pouches and then he'll hunt. And it's amazing. And then triggered by the sunrise, he will pump out about 95% of his bacteria, because if you let them sit there, they continue to repopulate and they'd explode. Not a good thing for the guy. So he pumps out about 95%. They're not glowing. He's not glowing, but that's okay. He goes and buries himself in the sand to sleep through the day. While he's sleeping, the bacteria start to repopulate. They go from 2 to 4 to 8 to 16, more. And there's enough of them when it's nighttime, when he pops up out of his burrow, that they all identify there's enough of them around and they turn on their group behavior of glowing right in time for him to hunt for the night. And so scientists are like, well, how do they know this? How do they know? And so as they began to study them, they identified that they were releasing this little hormone chemical. It's like a little I'm here chemical. And so if one of them is present, it's a little bit of chemical in the area. So it's not much for them to identify. If a bunch of them are present, which helps you identify how many must be in the area around you, some of that chemical will make its way into a specific receptor on the outside of the bacterium. And so if that receptor gets connected, it's specifically shaped by that specific I'm here chemical, it turns on its group behavior. So there has to be enough of that little I'm here hormone. So they're communicating. And not only did they discover that, they discovered all bacteria communicate, and they have species specific languages. There's their little chemical languages, and they have a trade language that they all understand. So based on how many of them are in an area and how many of other guys are in the area, that determines whether they want to perform their group behavior. And another group behavior that we know of is virulence, making you sick. So you have children, right?
Yep.
So when a child sneezes in your face, little 3-year-olds all, sick and condensed, just unable to breathe, and they sneeze in your face, you're like, I'm going to get sick. This is terrible. He sneezed in my face. And you know it, but you also know you're not going to get sick right away. And the reason is that some of the bad guy bacteria get into your body. And if you're not able to fight them off, they're going to reproduce and reproduce. And they're also going to send out their I'm here hormone. If there's not enough of them there, they're going to wait and they're going to determine how many other bacteria are around, how many of them are around, because you have about 150 species of bacteria living on or in you right now. Most of them are good. But the determining based on how many others are there and how many of them are there, they wait until that chemical is big enough. And then they turn on their group behavior. And within an hour, you're like, oh, I need to go on the couch. I don't feel so good. That's amazing. They communicate. We have learned that single-celled organisms, bacteria, can do practically anything that a multicellular organism can do. They can eat, they can hunt, they can reproduce, they can communicate, they can locomote, they can do all kinds of things as a single cell. And so when we say that organisms in the world go from simple to complex, it's wrong. Organisms go from complex to ridiculously complex. There's no simple organism. And so that makes us question, where did that first living organism come from? It had to be complete to be able to reproduce, to be able to feed itself all at one time. Any piece of that machinery that makes it do all the things inside had to be present simultaneously for the organism to live and perpetuate. And so the more complex we see the quote simplest organism, the more challenging it is to be able to say, well, where did it come from? Where did the first one come from? And outer space doesn't count as a reason, because then where did that one come from? A lot of people like to say, well, it came from outer space. Well, okay, where'd that one come from? Where did life start? And so it gets the conversation going, and it's fascinating because more and more data is coming in that's showing complexity, more complexity. And it just makes me, you can tell, makes me very excited.
Yes, I wish you'd been my science teacher at school, because they got a bit excited about science, but there's excitement and then there's excitement. And I wonder, this is a question for you to answer. Do you think your excitement comes from a certainty of the origin of what you're studying? Because I suspect, having had a conversation with you right now, that maybe the reason why they weren't quite so excited is they were excited about some of the science, but they had an incomplete understanding, because they would say, well, we don't know where it came from. Whereas you seem to have a certainty. So there's a sort of a really rubbishly asked question somewhere in there.
Well, yes. I mean, to me, it helps excite me about the origin of living things coming from, in my personal opinion, a creator. I see that in the scriptures. And when we see science discover those truths, and the same way we talked about the hydrologic cycle, it's like, wow, it's an affirmation in my mind. Not that I necessarily need one, but it gets me excited and I want to learn more, because the more I learn, the more I see evidence in a clearer way as to the magnificence, the power, the just of our creator. Just, he spoke things into being and boom, everything was there. And Big Bang, that's Big Bang to me. Boom. Everything, not simple, and with diversity and with ability to be diverse. And, we can talk about the different kinds of organisms and how we have variety now and how they came to be. And there's so many, everyone has a worldview. Let's just say that everyone, all scientists, everyone has a worldview. No worldview is a worldview. So everyone has one. And we take the discoveries, the information that we see, and we run it past our worldview and we process it that way. So every research paper is written with a worldview in mind. So it's always good to know the scientist who's putting out that information and just look at the data. If you disagree with their worldview, how would I interpret their research? How would I interpret their results? And to me, interpreting the results that I see in science always points to greater magnificence, greater glory, greater mystery solved, and also mysteries released, new ones that get me excited. That to me is the excitement of it all. It's a story that just is beautiful and elegant and blows my mind every time. So
fabulous. What's your story of faith then? Because you're talking a lot about faith through science. So
yes.
What was your journey? I mean, is it a church background? Did you have a kind of Damascus Road, the lights came on and you saw life differently? What was your background?
I think, mine was kind of a weird one in the sense that I was raised in the church, but it wasn't, I never really read my Bible. It was more of just a secular or just cultural thing. So I just, for whatever reason, never had opportunity to, or encouragement to read my Bible and realize that it was something that was living and real and true. So I was in college, just, in those years, you're kind of struggling with what is this whole world about? What am I going to do with my life? And that's where I really felt like several people had been instrumental in helping me to see that I needed to make a decision of faith and look into this. So I began to read my Bible, and I was like, wow, this is fat. It just instantly clicked. And I was doing it at the same time. Now I was a major in pre-medicine, was my major while I was at college. And at the same time I was reading my Bible for the first time, I was taking a course titled Evolution. It was a secular university. And so the course was evolution, and our textbook was Darwin's Origin of Species. So I'm reading my Bible for the first time, which is, God's revelation of how everything came to be. And I'm reading this book, which was man's revelation of everything came to be. And the first day of class, this is no lie, this is true. The first day of class, the professor said, other than the Bible, what is the one book that has changed the way that man thinks about the world? And I stopped and I said, you're excuse me, you're basically saying, other than number one, what's the number one? So you're basically taking away number one and saying, what's number one? So are you saying that the Bible's the book that changed the way man thinks about the world? Well, no. And he kind of backpedaled, like, you just said that. And so he knew I was going to be a troublemaker from the beginning of class, which I got an A in. But that started me on my journey of apologetics, why I believe what I believe. And if I truly believed that God created everything, then I should not be afraid to study our world. I should. And I think that that's a tendency that a lot of Christians tend to make about science. We're afraid of it because a lot of people, particularly, I'm going to throw this at you, particularly British accent, goatee wearing scientists will say, well, of course we know that scientists, that evolution occurred. And then you're very intimidated. Here in the US, we're intimidated by your accent because it sounds really smart. And so it's true. And so when I hear that, I'm like, oh, well, it must be true then. This guy sounds so smart. But honestly, we shy away, and it can be complicated. There's a lot to study. And so my goal is to encourage people that, first of all, we shouldn't be afraid of it, because if we truly believe that God created the world, then we should see that any evidences that we see can be explained by his creation. We may not know enough yet in some areas, but it's definitely something that we can know. And that's where I'm super excited. Our position, the Earth's position in our solar system's position in our galaxy, are specifically, perfectly Goldilocks position so that we can observe what's around us. Our atmosphere is one of only about 7 atmospheres, or 7 planetary bodies in our solar system that have atmospheres, and ours is the only one that's clear. So if we have to have an atmosphere to survive, but we have to have one where we can see the heavens. Otherwise, we wouldn't know anything about what's out there. And so we want, there's a question, is habitability and observability connected? Is there intention? We used to think that the Earth was the center of our solar system. We thought we were so cool about that. But then we learned that the sun was, and that doesn't diminish our position. In fact, the sun is there for us. The sun holds us in place. It holds the other planets in place. If Jupiter was not in orbit where it is right now, we would die. For a lot of reasons. We need Jupiter. So all the positions of all the planets, all the water molecule and how it behaves if it didn't behave the way it did, we would all die. I mean, I can tell you so many things. If it wasn't this way, we would die. If it wasn't this specific thing, we would die. And so it makes you question how this cannot be a convenient happenstance. There's purpose in this. We see order, we see purpose. And so it just fascinates me. It gets me super excited. And not just in the life sciences, in the physical sciences, in chemistry, physics. There's just so much. And I'm not an expert on all of them, but I love learning. And I think that we all should be, whether it's the sciences or history or poetry or anything else, we should all be students for our entire lives, learning more, because God gave us minds. He wants us to learn more about his world, and we have purpose. So that's my thing. I love it. So I continue to learn science because I love science and I love how it points to God.
Fabulous. Let's just go back to Disney World. You're working at Disney World. Yes. I'm presuming you got a degree of some sort. You then go to get a job at Disney World.
Yes.
What happened after that? Because you're now doing stuff that's not Disney World. So what was your journey into what you're doing now? What is it you do now?
Short answer, I became a mom. So that's a short answer. I was working and we, my husband and I, were newly married and worked for a couple years in that situation. And then I became pregnant, and I really felt that the Lord was calling me to be home with my children. And so most people thought I was nuts to do it. But I just really felt like God was calling me to be home. I wanted to be with my children. I wanted to be the one that was there when they took their first steps and walk with them. And not that there's anything wrong necessarily with working with your children. I'm not saying anything again, but God was calling me to stay home. And so I did. And so, but again, I still loved science. I still loved what I did. And so I began to, I would lead tours, educational tours out at Disney. I got connected with a company that found out what I did, and they asked me if I'd lead groups of tours. And so I would do that from time to time. And then I began teaching small co-op classes for homeschoolers. I would do summer classes, like week-long classes, dissections and things for private schools. I would go to our public school system and do like a career day thing. So I would do little bits and pieces, nothing like a career. But then I began to get connected with a publisher where I was able to write curriculum and teach. And now I'm doing that. So now that our kids are grown, I'm able to spend a lot more of my time doing these kinds of things to stay engaged.
Fabulous. What's the one thing that you've seen as a breakthrough in science, let's just say the last 10 years, that is the most exciting to you as somebody who has a faith in Jesus Christ?
Breakthroughs. I would probably say that it was the discovery of communication in bacteria. I really do. I think that to me, again, the biggest conversation that's out there in the creation evolution debate, or that's the biggest conversation of creation versus evolution in the Christian communities, science wise. And so to me, the origin of first life is more foundational in the discussion rather than this one species mutated to another species, which we could talk about endless as well. A lot of times when they say this is evolution in action, it's really not, because there's not more information, there's less information. When you hear superbacteria, that's evolution in action. Superbacteria are have less information in their genome than regular bacteria of the same types of species. So they're super only because they can't take in penicillin as well. But that's because they can't take in food as well, which means they're a weaker strain. And so there's a whole story about that. But so the origin of where life came from is still a complete mystery. And then when I see scientific research or papers come out trying to explain that from an evolutionary standpoint, it just excites me that they're grasping at straws. And I wish I had this handy. There was an article that came out in, I think it's Science Magazine, that they believe that octopuses came from outer space. Only because they're very different than the rest of organisms in creation. And I was like, based on, and I read based on nothing. There's no scientific evidence of that. It's just that they're different. So they must have come from outer space. And this isn't science fiction. This is science saying this. And so what excites me, it saddens me that they're still turning their head away from that. But it excites me in the sense that there's fewer and fewer scientific explanations that they can come up with. So to me, this is a spiritual battle, because as a scientist, if you hold to evolutionary theory and you keep seeing problems, red flags, issues come up, it's a spiritual battle, because if you would have to then say, well, maybe there is creation. Well, then I need to understand what that means with my worldview, my whole life-changing worldview. If there's a God, then what does that mean for me? And so it's a personal spiritual issue, I believe, which is why it's fought so hard, because it's a bigger issue than just, I don't know, how do we see red light in our eyes? That's different. That's not fought hard. But this other is, because it has a greater conclusion that faces us, groundbreaking in our minds and our spirits. So that's where I love to live and talk about and encourage. But I also think that we need that foundation of understanding science, so that then we can take it and hold it up against what we're discovering and say, well, then why aren't they giving us some explanation here? And truly, octopuses are very similar in design as other mollusks. They are a unique type of mollusk, but they have similar body structure, believe it or not. They're just cooler. They've got a humongous adaptation to be able to survive, and take shape and think and solve puzzles. They're brilliant. And so, and yet they're very similar in design to a clam. It's just fascinating. So yes, but that's where I love that. That's probably my most exciting. And because it's a life science, I do truly, my background is in life science. And so I love that. And then I'll have to add discovering new organisms in the ocean. So just gotta love that. That just blows my mind too.
I read recently, actually, somewhere completely different, incidentally, about how the reason why space is easier is because it's terrifying. It's easy to put an astronaut on the moon than it is to put a diver on the ocean floor.
Yes,
because it's actually easier. It's less complicated, which
it is.
blows my mind.
Yes, I mean both locations require us to have a supply of oxygen, so that's identical, right? But you've got extreme pressure under the ocean. You've got the causticness of the salt water. So any container that you have that you're living in has to be able to endure not only massive pressure, but rust formation and sealing. The seals, there's no pressure in outer space. So it's kind of the reverse there. And so it's easier to control. I'm not saying it's easy, because believe me, I'm sure it's very, very difficult. But in comparison, there's a lot more details to get to and to consider in maintaining a human down the bottom of the ocean than maintaining one up in outer space. So, it's definitely more difficult, which is why we send robotic cameras and things down into the ocean, because we can keep them down longer rather than sending a human down there.
And they can't die, which is good.
And they can't die. That's right. But they do try to take samples of organisms in containers and bring them up, so we can look at them. But the problem is the pressure up at the surface of the ocean is so much less than what those organisms are used to. They die. So they can't live up here and we can't live down there. And so it poses some problems for us to study them.
Yes. Well, I can understand that. If we die down there and they die up here, then yes, we can't.
Yes.
You can't stick them in a box and bring them up again, can you?
No, you can't. It's not good. It's not a pretty sight. So.
I can appreciate. Right. Sherri, thank you so much. I could talk for hours. I need to draw it off somewhere. So I'm going to draw it off here. The idea of, the surface of the planet is something we still don't know enough about. I saw it was a minister in the UK who was at Oxford University, I think, Oxford or Cambridge. And he was having a conversation about faith and belief. And they said, you can't be right. We know that we're right. And this minister had this inspiration. He drew a big circle on this board. And he said, right, if this is all knowledge forever, how much of this do you think that you personally know? And this guy came along, drew a little dot. He said, right, well, if all of this is all the knowledge and you know this teeny tiny little piece that's not even a dot, how can you say that you know anything if you don't know basically everything else? And I think that's what I love about the wonder of what you're talking about, is there's so much we don't yet know.
Yes. That excites me. That really does, because it's a discovery. We're all explorers. And so I would tell my children, we're doing research. The search and research is the exciting part, to be able to search and hunt and discover. And that makes it, they put on their Sherlock Holmes hats and they're like, yeah, let's go search, because that's what education is. And we have been given minds to know. God has given us minds to know and to learn. And so we should be doing that. That's our occupation, as part of this, and having these conversations is wonderful too.
Fabulous. Sherri, thank you so much. It's been a joy to talk to you so far.
You too.
I'm really privileged that I get to have conversations with some amazingly diverse people. I was talking to somebody earlier about socks, and now talking to you about marine biology, which is fascinating, and actually giving you giving you over to people to learn more about. Can people do you have stuff that people can read, or is there a source, a website that people can go to?
Yes. Well, I have just a stationary landing page website, my first and last name.com, sherriseligson.com. You can find me on social media as well. I'm on Instagram and Facebook. And then the publishing company that publishes my educational videos and my curriculum that I write is called apologia.com. So you could, if you feel like picking up a marine biology textbook, there you go. Something, if you can't sleep at night, open it up and read. It'll put you right to sleep. That's what I tell you. It's great for insomnia. No, but there's also instructional videos that we have that accompany all of our courses. And so I film those on location so we can bring science to students to make it more exciting.
Oh, fantastic. Thank you so much. This has been really good fun. I loved it. Following you for a decade and to actually be able to talk to you and introduce you to others as well is fab. For me, from the hydrological cycle to what was it? The bioluminescent squid. I mean, it's phenomenal. And I love that. So thank you for exciting me again about science. I wish you'd been my teacher at school. Although you're probably not even close to old enough for that. But yeah, that'd have been great. Thank you so much, Sherri.
Yes, Andy. Thank you. So wonderful being here. It was enjoyable talking with you.
Pure 24/7 radio is listener supported, which means we are free, online and always pure because of the generous support of our listeners. If you would like to contribute financially, please visit pure247radio.org. If you'd like to find out how we use your money, please visit the Our Cost section. Any donation of any size will help keep us on air and broadcasting for free. Thank you.